Hi everyone, welcome to another lesson in general physics. Today's lesson is about friction. Let's begin. So what is friction? Friction is the resistance to the sliding, rolling, or flowing motion of an object due to its contact with another object. When a moving object comes in contact with another object, friction is the opposing force that slows or stops the moving object. Without friction, an object would continue to move at constant speed forever. The strength of the force of friction depends on the type of surfaces and how hard the surfaces push together. In these, rough surfaces produce greater friction than smooth surfaces. There are four types of friction. The first one is rolling friction, static friction, sliding friction, and fluid friction. So let's discuss them one by one. What do all these things have in common? You can say that they are all rolling or have rolling friction. Rolling friction is the friction that occurs between surfaces in motion in which one of the surfaces is wheel, roller, or ball. Examples of this is bicycling or riding a bike in which the friction is between the tires and the ground. Another thing is bowling. On bowling, the friction is between the ball and the lane. Looking at the illustration, what do all these things have in common? So we have books, laptop, and a cell phone. Well, you might say that these are used for online learning. But what are the association of these things in friction? So these things possess static friction. When we say static friction, it is the friction that occurs when the surfaces in contact are at rest or not in motion. Examples are a book resting on a table or a desk, and a potted plant sitting on a sidewalk. The third one is, what do all these things have in common? A sliding window, a boy sliding, and two players playing hockey. So these things are common when it comes to sliding friction. So sliding friction or kinetic friction is friction that occurs when solid surfaces slide over one another. Examples of these are writing, in which the sliding friction is between the pencil point and the paper. Or when you are combing your hair, in which the sliding friction is between the surface of the comb and the strands of your hair. So by looking at these three illustrations, what do all these things have in common? We have an airplane, a paraglider, and a swimmer. So these things all possess fluid friction. The force that tries to slow objects down when they move through a liquid or gas. It is also known as drag or air resistance. So all gases and liquids are fluids. Therefore, an airplane or a swimmer both experience fluid friction. There are also some ways to reduce this friction. The first one is smooth surfaces. So smooth surfaces possesses low friction. Therefore, it is one way to reduce the friction acting upon objects. The second one is replacing rolling with sliding. Sliding has lower friction compared to rolling. And the third one is to add oil or another type of lubricant. So the use of lubricants, wheels, rollers, and ball bearings reduces frictions. Lubricants like grease and oil smoothen the surface between two bodies in contact. So water can be a lubricant too. Floors and roads are slippery when wet because water tends to smoothen their surfaces. So a slippery road will not give tires the grip they need. And the tread design preserves friction between the wet road and the tire. So the water goes to the spaces in the tread pattern instead of coming between the tire surface and the road surface. Now, there are also some laws governing friction. So the following are the laws governing sliding friction and static friction. The first one is static friction is greater than kinetic friction in magnitude. So experience tells us that we need to exert a greater force to start motion than to maintain it. The second one is that friction acts parallel to the surfaces in contact and in direction to oppose motion. While friction cannot produce motion, therefore its main role is to oppose motion. The third one is friction is independent of the area of contact and speed of sliding. We all know that the speed affects how high friction is. The fourth one is friction is proportional to the normal force. And the last one is friction depends on the nature of surfaces in contact and conditions of surfaces. That is, whether the surfaces are rough, smooth, polished, or wet. So rolling friction is treated in the same way as sliding friction. Rolling friction is proportional to the normal force and its magnitude is less than that of sliding friction. The laws of viscous friction are totally different from those of sliding and rolling friction. So viscous friction depends on the area of contact and relative speed of fluid and body, while the air resistance encountered by a falling body is an example of a viscous friction. Viscous friction will be discussed in detail in the latter section. Now let's move on and dealing further with static friction and kinetic friction. On this lesson, we're going to discuss how do we compute this and involving different word problems. Consider an object resting on a horizontal surface to which a horizontal force is applied. The free body diagram of the object is seen on the illustration. So let us further assume that the value of F may be gradually increased. At all times that the object remains at rest, the applied force is balanced by its static friction. Increasing the applied force also increases friction. However, static friction has a maximum value. If the applied force exceeds the maximum value of friction, then the object will start to slide and accelerate in the direction of the applied force. Also know that the normal force is vertically equal to the gravitational force. In here, gravitational force is equal to mass times gravity, which is 9.8 meters per second squared. While normal force is equal to the gravitational force since they are vertically together. And friction force is equal to the applied force. Static friction is maximum when motion is about to begin or when motion is impending. So the force of static friction keeps a stationary object at rest. The maximum value of friction is found to be proportional to the perpendicular or normal force pressing the surfaces together. It has an equation of F sub s is equal to F sub n times mu s, where mu s is called the coefficient of stationary or static friction and is a property of the materials in contact with each other, while F sub n is the magnitude of the normal force. Now, how about kinetic friction? Once the two surfaces begin to slide over another, static friction is replaced by kinetic friction. Once the force of static friction is overcome, the force of kinetic friction is what slows down a moving object. It has an equation of F sub k is equal to F sub n times mu k, where mu k is the coefficient of kinetic friction. F sub n is the magnitude of the normal force. In kinetic friction, it is found to be proportional to the normal force. So the normal force is the force that is 90 degrees to the surface, or the normal is 90 degrees. In the illustration, to initiate motion of the box, the man must overcome the force of static friction. While in this one, upon sliding, the baseball player will come to a complete stop due to the force of kinetic friction. Now here is the table for static and kinetic friction coefficient. We have the different materials like rubber on glass, rubber on concrete, steel on steel, wood on wood, metal on metal, ice on ice, and synovial joints in human. Notice that the coefficient for static friction and the coefficient for kinetic friction are different with each other. Now let's move on solving different word problems involving static friction and kinetic friction. For example, a 30-kilogram brick is laying on a table, not moving. What is the normal force? On our first discussion, gravitational force is equal to mass times gravity, which is also equal to the normal force, and the normal force is equal to the gravitational force. From this equation, let us use this one. So mass times gravity is equal to the normal force. Substituting the values given to the equation, we will have normal force is equal to the mass is 30 kilogram and gravity, or the acceleration due to gravity, is equal to 9.8 meters per second squared. Multiplying 30 and 9.8 will have an answer of 294 newtons. Therefore, on this problem, the normal force is equal to 294 newtons. Here's the next one. What is the force of friction acting on a 10-kilogram rubber block sliding on a concrete, assuming that mu is equal to 0.65? So our solution would be, from the equation, in getting the kinetic friction, we have F sub k is equal to S sub n times mu k. Substituting the values given to our equation, we will have our normal force can be computed by multiplying the mass and gravity. So on our given, we have 10 kilogram rubber, so this is the mass, multiplied to the force of gravity, or the acceleration due to gravity, is equal to 9.8 meters per second squared. So that's Fn, multiplied to mu k. On the problem, our coefficient is equal to 0.65. So solving, 10 times 9.8 will have 98 newtons multiplied to our kinetic coefficient. So 98 newtons times 0.65 will get kinetic friction equivalent to 64 newtons. Let's move on with sample problem number 3. What is the force of friction acting on a 100 kilogram crate rest on a rough horizontal surface? The coefficient of static friction is 0.500. So in solving this, we're going to use the equation F sub s is equal to F sub n times mu s, since the given is in static friction. Substituting, again, the normal force can be computed by multiplying mass times acceleration due to gravity. On the given, our mass is equivalent to 100 kilogram. Then the acceleration due to gravity is equal to 9.8 meters per second squared. Then our coefficient of static friction is equivalent to 0.500. So 10 times 9.8 will get an answer of, or 100 kilograms times 9.8 meters per second squared. We're going to get an answer of 980 newtons multiplied to the coefficient of the static friction, which is 0.500. And the answer is 490 newtons. So in this problem, the force of friction is equivalent to 490 newtons. Here's another simple problem. A hockey puck is hit on a frozen lake and starts moving with a velocity of 13 meters per second. It travels across the ice, and 6 seconds later, the velocity is 7 meters per second. What is the coefficient of friction between the puck and the ice? So, in order for us to get the answer for this, we have to first solve for acceleration, since it is not given on the problem. So, to solve for acceleration, we're going to use the kinematic equation. Final velocity is equal to initial velocity plus at. Substituting the given on our equation, so our final velocity is equal to 7 meters per second. Our initial velocity is equal to 13 meters per second, and our time is equivalent to 6 seconds. So simplifying this equation would be 7 meters per second minus 13 meters per second is equal to 8 times 6 seconds. 7 minus 13 will get an answer of negative 6 meters per second. So, in able to get the value for A, we have to divide both sides by 6 seconds. So, negative 6 meters per second divided by 6 seconds will get an answer of acceleration equals to negative 1.0 meters per second squared. Now that we already got the value for acceleration, now that we already got the value for acceleration, which is negative 1.0 meters per second squared, let's proceed on getting the value for the kinetic friction. But in order for us to do that, we have to first derive a formula. From the previous discussion, the net force is equal to negative kinetic friction, and the negative kinetic friction is also equal to the horizontal motion. We can also say that the negative kinetic friction is equal to the coefficient for kinetic friction multiplied to net force. Net force can also be written as mass times gravity. Since negative horizontal motion is equal to the negative kinetic friction, we can say that mu k times mass times gravity is equal. Therefore, we can use the equation mu k is equal to the horizontal motion divided by mass times gravity, or acceleration in the horizontal motion over gravity. So let's use this. Mu k is equal to negative acceleration divided by gravity. Substituting the given on the formula, we will have our acceleration is negative 1.0 meters per second squared divided by our acceleration due to gravity is 9.8 meters per second squared. So, negative 1.0 meters per second divided by 9.8 meters per second squared will get an answer of 0.10. Therefore, this is the coefficient for kinetic friction. Now let's move on solving our last problem. Sample problem number 5. A 248 kilogram object moving at 19 meters per second comes to a stop over a distance of 38 meters. what is the coefficient of the kinetic friction between the surfaces. So in able for us to solve for the coefficient of the kinetic friction, we have to first get the value for acceleration using the equation final velocity squared is equal to initial velocity squared plus 2AD. On our plus problem, time is given. This time, the distance is given, which is 38 meters. So, substituting the given to our equation, final velocity is equal to 19 meters per second plus initial velocity is not included or not indicated, therefore it is 0, plus 2a multiplied to our distance, which is 38 meters. So 19 squared will get an answer of 361 meters squared over second squared is equal to 2a times 38 meters. And able for us to get the value of a, we have to divide both sides by 38 meters. So 361 divided by 38 will get an answer of 9.5 meters per second squared. Since there is a remaining 2 as a coefficient of acceleration, we further divide both sides or further divide 9.5 meters per second squared divided by 2. We'll get an answer of acceleration which is equal to 4.5 meters per second squared. In here, acceleration is negative since the motion is horizontal. Now that we already computed for the value of acceleration, let's move on and computing the coefficient of kinetic friction by using the formula. Kinetic coefficient is equal to negative acceleration divided by gravity. So our acceleration is negative 4.5 meters per second squared divided by our gravity, which is 9.8 meters per second squared. So negative 4.5 divided by 9.8, the coefficient of kinetic friction would be 0.46. And that's it for our discussion on friction. Thank you for watching. And remember, think like a proton, always positive. See you all in our next discussion.